All right, pre-calc fans. Today we're looking at domain restrictions on the domain. So our first domain restriction that we have is called when we have undefined fractions. Okay, so a fraction is undefined or meaningless when a 0 is in the denominator. The domain of a function must be restricted for all values that would result in a 0 in the denominator. To determine the value that must be excluded from the domain, set the denominator equal to 0 and solve for x. So I literally look right here. What makes the denominator equal to 0? So x plus 1 equals 0. So x equals -1. So the domain then, we would just say x does not equal -1. We could say, the domain is all real, x does not equal -1. Okay? What's another way of us saying all real, by the way? That's right, using our interval notation, that would be -infinity, comma, infinity, with parentheses. So that means all real. Okay. All right, what about here? Yes, we're going to have a fraction, no big deal. All you care about is the bottom. We do not care about the x on top. Okay, so set the bottom equal to 0. So that's x is equal to 6/4. Remember, I added 6 divided by 4, so 3/2. So all real, x does not equal 3/2. Now, so I'm going to skip that one. Let's do some factoring fun. Okay. Now, what happens here? Do you care about the top? No, all we care about is the bottom. So x squared minus 5x plus 4 equals 0. It's nice and factorable. -4 minus 1. So x equals 4 and a 1. Okay, so technically x does not equal 4 and a 1. So your domain is x does not equal 4 and a 1. So technically speaking, if I'm telling you what x does not equal, I don't need to say all real. If you want to, you can have fun and you can do your symbols. Or we could just use all real, the fancy R. Okay. Let's do number 6. Last of the factoring ones here. So remember, you don't care about the top, all we care about is the bottom. So x squared minus 7x equals 0. How are we going to factor this? That's right, GCF. So x minus 7. So x does not equal 0 and 7. So x does not equal 0 and a 7. Okay? And we can be fancy. All real, x does not equal 0 and a 7. Okay? So undefined fractions. So from last year, what other numbers were not real numbers? That's right, imaginary numbers. So that's negatives underneath the radical. A radical is only defined in the set of real numbers. When the number under the radical, the radicand, is zero or a positive number. Okay, so in other words, 0 or positive, that is greater than or equal to 0. So to find the domain of a function that has a radical, set the radicand, that's the stuff underneath the radical, expression under the radical, set the radicand greater than or equal to 0 and solve for x. Okay, so here we are. We're going to set the stuff underneath the radical greater than or equal to 0. So all I got to do is add 4. There we go. There's your domain. So now we don't say all real, because it doesn't make any sense, because we have a whole bunch of numbers that we cannot include. So now we just say x is greater than or equal to 4. All right, doing the same thing. So 10 minus 2x is greater than or equal to 0. Okay, I'm going to subtract 10. And I'm going to divide by negative 2. What happens when I divide by a negative 2? Remember, that's right, we have to flip the inequality. So be very, very careful when you're doing these. So it's x is less than or equal to 5. Remember, when you divide by a negative, flip your inequality. So the domain is x is less than or equal to 5. Okay. Divide by a negative, flip the inequality. All right, I'm going to skip this one. All right. Now what happens? What happens if the radical's in the denominator? Oh, look at that, radical's in the denominator. Do we say equal to 0? No, we can't say equal to 0, because if it's equal to 0, then we're dealing with an undefined situation. So if the radical is in the denominator, then set the radicand strictly greater than 0. Because if it's equal to 0, we can't have zeros in the denominator from the other side. Okay, so 2x plus 8 is strictly greater than 0. So that's just our algebra. So 2x is greater than negative 8. X is greater than negative 4. I did not divide by a negative. I don't flip the inequality. So the domain is x is greater than negative 4. All right, over here, now this is 1, so that says 6 minus 3x, if you can't see it because of the line from the copy machine. That says 6 minus 3x, so I have 6 minus 3x. Remember, we don't care about the top. Okay, not yet anyways. So that has to be strictly greater than 0. So I'm going to subtract 6. And then I'm going to divide by the negative 3. And when we divide by the negative 3, that's right, don't forget to flip the inequality. So x is less than 2. Okay. No restrictions. No restrictions literally means no radicals, no x's in the denominator. So if a function does not involve a radical, or I'm going to say, I don't want to say a fraction, because I mean I could have 2/3, but there's no x in the denominator. I'm going to say x in the denominator. Then the function is, the domain is the set of all real numbers. There are no restrictions. Okay? So, again, remember, you can use your fancy script R, or we can say, write out the words all real, or else we can use the negative infinity to infinity. Okay? All right, so yeah, any fractions? No. No. Any x's in the denominator? No. Any radicals? No. So all real. Same thing here. All real. I'm going to be fancy. All right. You'll see that in your homework.